Okay, so let's sketch a graph that's a little bit more complicated than the one that we did before. This is going to be sketch the graph of r equals sine of 3 pi. So uh, one of the things that you'll find about this is that it sort of stretches the limits of what you think you know about angles and trigonometry, because you're going to find yourself saying, well, wait a minute, I thought that we were at the angle pi, and it turns out we're at the angle pi over 3. So try to follow along here. I've written in the values that I want to consider. So I know these look a little bit strange, but you're going to see why in a minute. So first of all, let's put in the point 0. So we know that if we choose, sorry, these should not be 0, these are theta. So if I put in the point theta equals 0, then r is going to be sine of 3 times 0, or sine of 0. So that just gives us the point 0, 0. In other words, point of radius 0 is always going to be at that spot. It doesn't really matter what the angle is. Okay, now let's consider the angle pi over 18. That's a very, very tiny angle. That's if pi over 6 is 30 degrees, so this is actually about 10 degrees. So let's just draw it in like that. Now look what happens. If I put in theta, I know that normally we don't know what sine of pi over 18 is, and we still don't. But remember that the function we're given is sine of 3 theta, not the sine of theta. So if theta equals pi over 18, then r equals sine of 3 times pi over 18. That's going to be pi over 6, and we do know that the sine of pi over 6 is 1/2. So this is what I meant when I said you're going to sort of get confused about which angle we're talking about. The theta that we're given is actually this 10-degree angle that I've drawn in here, but since we're multiplying theta by 3, when we actually calculate sine, it starts to look like pi over 6. That doesn't change the fact that we are, in fact, at pi over 18 when we graph this point. So what I've put in here is a unit circle. This red dotted circle is 1 unit. And what we can see is that we're getting a radius of 1/2. So what I want to do is go 1/2 the way to the unit circle. So that's going to be our next point there. Okay, pi over 6, that's going to be the familiar 30-degree angle, which I will put in as roughly like that. And what we see is that when I put in pi over 6, even though normally we know the sine of pi over 6 is 1/2, I'm multiplying the angle by 3 when I plug it in. So r is going to be sine of 3 times pi over 6, which is 3 times pi over 6 is pi over 2, and we know that sine of pi over 2 is 1. Now, I know many of you say, oh, okay, I know where sine of pi over 2 equals 1 is. That's going to be there, right? But no, because just because we know that normally if I were graphing on the unit circle, I'd say sine of pi over 2 is 1, which would put me right about there. The actual angle I've been given is pi over 6. So what I need to do is for an angle of pi over 6, my function is telling me that the radius is 1, so I need to put a point here at an angle of pi over 6 and a radius of 1. Now, let's go back to let's go to the next angle, pi over 3. That's about the angle pi over 3, and when I plug in pi over 3, I get 3 times pi over 3, which is pi, and I know the sine of pi is 0. So that puts me back here. Now let's try to put this all together and see what happened. Assuming that I'm going to graph a smooth function here, the first part of our trip took us out there, and then what we see is that after I get to this angle pi over 6 and go up to angle pi over 3, I keep turning. In other words, I keep turning clockwise, but I also am somehow going to get back to 0, which means that the path, although I know I didn't put in points for this, that I trace looks like that. This looks a little bit like a flower petal, and actually that's where it gets its name from. This shape is called a folium, or foliage means leaves, I guess. Also means flower petals, which are just adapted leaves. So this shape is called a folium, and this shape, the loop that we've drawn here, is actually called one petal of the folium. So all right, so let's look at what we've done here. We started at oops, we started at theta equals 0, and our function told us to keep increasing the radius as we went out. We got further and further. We eventually got up to 1 here. That's as high as it went. And then as we kept turning around the circle, we got up to here. We got up to pi over 3, but that brought us back to a radius of 0. So that's how we ended up drawing this folium. If you want to, you could try as an exercise plugging in some point here, like let's say you can do this yourself with a calculator, but if you plug in the point pi over 4, where you're going to get sine of 3 pi over 4, which is root 2 over 2, that's going to take you roughly to this point here. So you can sort of get a sense of how you get this loop as you graph this function. Now, we're at this point. We are right there. So what happens next? Let's go to the point pi over 2. So, or sorry, the angle pi over 2. So we know that pi over 2 is going to be this vertical line here. If I plug in pi over 2, then I get the sine of 3 pi over 2, which gives me negative 1. What that means is that I want to walk negative 1 in this direction. And we've already talked about this, that if the direction that I have is straight up, but I'm walking in the negative direction, then that takes me straight down. So for pi over 2, the point is there. Now, again, I know many of you are looking at this and saying, this purple dot that I just put in looks like it's at 3 pi over 2 or negative pi over 2. You have to realize that the angle is simply an argument to a function which can have positive or negative values. So this point here is negative 1 unit in the direction of pi over 2. I should probably do that in red. This is the pi over 2 ray. In other words, this ray makes an angle of pi over 2 at the x-axis, but I'm walking negative 1 units in that direction, which takes me down here to this purple point that you see on the bottom. If I were to graph what's going on, that as I keep turning around the circle from here to here, I'm getting negative values. You can try one of those. You can try, an angle between pi over 3 and pi over 2, put it into your calculator. Take an angle somewhere in between there. I guess we don't have a good one on the unit circle that's for a known angle, but just pick a value that's between pi over 3 and pi over 2, multiply it by 3, and calculate the sine. Make sure you've set your calculator to radians. You will, or it's not going to make any sense. You'll see that you're getting negative values as you travel from this angle up to here, and those negative values means that we're going to be in this territory down here. So as I graph this, what happens is it's going to look like that. Then what we see is, let's go up to here, to 2 pi over 3. 3 times 2 pi over 3 is 2 pi, and we know the sine of that is 0. So as I'm turning around to this angle, which is 2 pi over 3, I'm still getting negative values, which keep me in this territory. So that's where that loop is going to go. And then finally, sine 5 pi over 6, that takes me, this is sine 5 pi over 6. Now I'm getting a positive value, so sine 5 pi over 6, I actually go 1 unit in the positive direction along this ray, which is at the angle 5 pi over 6, and that takes me out here. So you can sort of see if I follow the curve around, it goes back there, and then finally at the angle of pi, which is here, I go back to a 0 radius. So as I approach the angle of pi, I go there, and we can see that r equals sine of 3 theta is this 3-petaled flower. I can't guarantee you that it's always going to be sine of n theta gives you an n-petaled flower. Sometimes the petals actually sort of wrap around on themselves. But in this case, r equals sine of 3 theta does give you a 3-petaled flower. So that's the graph of r equals sine of 3 theta. And it sort of forces you to think about where you are as you turn through the circle, and whether you're in positive or negative territory, and what that even means in polar coordinates. So hopefully that example was instructive.